The last photograph, before everything failed. It was captured in an ordinary moment, framed without drama, and stored alongside thousands of routine images. Yet it became the final record of a mission that would soon unravel beyond recovery. Nothing in the photograph itself hinted at catastrophe, which is what makes it so unsettling in hindsight. To understand why this image still matters today, we need to examine how deeply modern exploration relies on visual confirmation. Photographs from space are not just documentation, they are proof of health, progress, and control. Engineers read them for subtle signs, scientists analyze them for data, and the public sees reassurance that everything is unfolding as planned. In today's missions, images remain one of the most trusted indicators that a spacecraft is alive and functioning. That trust shaped the interpretation of this photograph. At the time it was received, the image appeared perfectly ordinary. Structures were intact, lighting was nominal, and no anomalies stood out to the teams reviewing it. Telemetry supported the same conclusion, suggesting that the mission was proceeding within expected parameters. There was no reason to linger on the frame or flag it for further scrutiny. But within hours, the first signs of trouble emerged. Communications became irregular, systems reported conflicting states, and commands failed to produce expected responses. What initially seemed like a minor disruption quickly escalated into a cascade of failures, each compounding the next. As controllers struggled to regain control, attention returned to the last confirmed data points, including that final photograph. Only then did its significance begin to change. What once looked normal became a boundary, a dividing line between order and collapse. The image marked the last moment when the mission could still be said to exist as intended, before a chain of events pushed it beyond the reach of recovery. As engineers retraced the mission's final hours, the photograph became a focal point, not because it revealed failure, but because it revealed none. Every visible component appeared stable, aligned, and uncompromised, reinforcing how deceptive normalcy can be in complex systems. Spacecraft do not always fail with warning signs. Sometimes they fail quietly, beneath layers of data that appear reassuring until they are suddenly irrelevant. Investigators synchronize the image with telemetry streams, command logs, and system timelines, attempting to pinpoint the moment when stability began to erode. What they found was not a single trigger, but a subtle divergence between expectation and reality, where small inconsistencies accumulated without crossing any immediate thresholds. Each system operated within limits, yet together they drifted toward a state no model had anticipated. This is where the image gained its unsettling power. It represented the last confirmation that human understanding still aligned with the spacecraft's condition. After that point, interpretation lagged behind reality. Controllers believed they were interacting with a functioning system, while the system itself was already moving beyond recoverable states. As failures compounded, options narrowed. Redundant pathways were exhausted. Recovery commands arrived too late or met systems no longer capable of responding. The mission did not collapse in a single dramatic instant, but through a quiet loss of coherence where control slipped away incrementally until it was gone entirely. The photograph, frozen in time, became a reminder of how fragile certainty can be. It showed a spacecraft that looked alive, functional, and obedient, even as the conditions that would end it were already in motion. In that sense, it captured not failure, but the illusion of control that often precedes it. The conflict reached its most painful point as investigators confronted the realization that nothing in the available data had clearly demanded intervention before it was too late, because the systems failed in a way that remained technically acceptable until recovery was no longer possible. This was not a story of ignored alarms or reckless decisions, but of complexity quietly overwhelming foresight. As analyses deepened, it became clear that the mission had entered a zone where small deviations interacted in nonlinear ways, amplifying each other without triggering explicit warnings. Software interpreted conditions as manageable, hardware responded as designed, and human operators followed procedures that had worked countless times before. Yet together, these correct actions produced an irreversible outcome. What made this moment especially unsettling was how familiar it felt. Many previous missions had experienced minor anomalies and recovered successfully, reinforcing confidence that gradual degradation could always be corrected. That history shaped expectations, making it difficult to recognize when a situation had crossed from recoverable to terminal without announcing the transition. Emotionally, the loss carried a heavy weight. Teams who had spent years building, testing, and guiding the spacecraft were forced to accept that the mission had ended not through dramatic failure, but through a sequence of reasonable steps that collectively led nowhere. There was no single mistake to learn from, no clear villain to blame, only a sobering lesson about limits. The final photograph came to symbolize this conflict between perception and reality. It showed a spacecraft that appeared healthy, even as it slipped beyond human reach. In that gap between appearance and truth, the mission was lost, leaving behind a question that would echo through future designs. How many other systems look stable right up until the moment they are not? The climax of the investigation arrived with acceptance rather than resolution, as teams concluded that the mission had not failed in a way that could be fully prevented, only better understood. The photograph did not conceal a hidden flaw or overlooked warning. Instead, it revealed the limits of interpretation in systems where complexity outpaces intuition. From that acceptance came change. Design philosophies began to shift toward recognizing subtle interactions rather than isolated failures, and monitoring strategies evolved to search for patterns of divergence instead of single points of breakdown. The loss reshaped how missions define safety, emphasizing anticipation over reaction and humility over confidence. The resolution extended beyond engineering. The image became a teaching tool, reminding future generations that certainty in space exploration is provisional, dependent on models that simplify realities too vast and interconnected to be fully captured. The photograph's power lay not in what it showed, but in what it failed to reveal. Today, that final image still circulates in training sessions and technical discussions, a quiet witness to the moment when control gave way to complexity. It stands as a reminder that exploration is not defeated by error alone, but by the limits of understanding. Sometimes the most important lessons are learned not from dramatic failures, but from the moments that look perfectly normal right up until everything changes. Subscribe to join the journey.